Hello students. In today's session, we are going to study practical organic chemistry. And in case of practical organic chemistry, we are going to learn qualitative analysis. Qualitative analysis means what is present in the given compound. That is nothing but termed as a qualitative analysis. Similarly, what is present, if we are going to determine that in terms of how much it is present, that type of analysis is called as quantitative analysis. Now in case of qualitative analysis, we are going to detect presence of carbon, nitrogen, sulfur, halogen, and phosphorus and phosphorus. So in order to detect the carbon presence in the organic compound, carbon containing a compound is taken and it is heated with cupric oxide. We want to write here oxidation state so that we can term it as cupric oxide, where carbon is converted into carbon dioxide. Similarly, the hydrogen present in the organic compound, if it is heated with cupric oxide, it will be oxidized into H2O plus copper. Now the carbon dioxide formed is treated with lime water. Then lime water turns milky because of the formation of calcium carbonate. So this formation of calcium carbonate, where lime water gets converted into milky, confirms that the compound contains carbon. Similarly, the water vapor formed, if it is treated with copper sulfate, and this copper sulfate is white in color, or we can also term this copper sulfate as anhydrous copper sulfate, which will be converted into copper sulfate with 5 molecules of water. At this point, we can say that the color of this compound will be blue, or we can say that simply it is hydrated copper sulfate, where it is accompanied by 5 molecules of water. Thus, the presence of carbon in the organic compound can be detected by these following reactions. Next, we are going to detect nitrogen. So this detection of nitrogen is usually termed by the name which is called as Lassigne's test. It is also called as sodium fusion extract, simply termed as SFE. In order to understand this Lassen's test, we require sodium metal and a small fusion tube into which organic compound is taken. Initially, a small pinch of sodium metal is taken in this sodium fusion tube, and it is gently heated on a Bunsen burner, where the sodium metal will be converted into a shiny globule like appearance. At that instant of time, with the help of a forceps or with the help of spatula, we are going to add a little amount of organic compound for which nitrogen can be detected. After adding, the fusion tube is again heated to red hot temperature on a Bunsen burner. After heating for red hot temperature, the tube is then plunged. The word plunged means break. It is braked with the help of a pair of tongs into a china dish containing 10 ml of distilled water. After transferring the contents into a china dish containing 10 ml of distilled water, this word is important, distilled water, it means that it is free from chloride ions. And now the contents are then again heated on the Bunsen burner, and after heating for couple of minutes, the contents of this china dish are again transferred into a test tube by filtration. By filtration. Now the filtrate is called as sodium fusion extract. The point we should remember is that this sodium fusion extract must be completely colorless. If at all, if there is any colored precipitate or something else, then we should come to conclusion that the organic compound has not fused completely with the sodium metal, and we have to repeat the whole process once again. Now, this extract is used for detection of not only nitrogen but also for sulfur, as well as for halogen, and lastly phosphorus. We can divide the Lassen's extract into different available forms so that we can complete the test one by one. Now let us try to understand how we are going to detect for nitrogen. So basically we know that we are going to add a sodium element to the organic compound containing carbon and nitrogen. So therefore Na, C and N together they are going to react and we get sodium cyanide. At this moment we are going to add freshly prepared ferrous sulfate. When we add freshly prepared ferrous sulfate to sodium fusion extract, we will be having ferrous cyanide. Now ferrous cyanide formed, it is going to react further with excess of sodium cyanide. Excess of sodium cyanide, here sodium is 4 times, so therefore we can write here 4 sodium, then obviously Cn will be here 4 plus 2 6, and the name of this compound is sodium ferrocyanide. Sodium ferrocyanide. Now to this sodium ferrocyanide, we are going to add neutral FeCl3 solution. When we add a neutral FeCl3 solution, we will be getting Fe4 FeCl 6 times, then 3 plus NaCl. Now here Fe is 4 times, so therefore we can write here 4 times. 4 into 3, 12, though halogen I can write here 12 times. Now sodium becomes 12 times, so I can write here 3 times. And now this whole part will become 3 times, so I'm going to write here, already it has been written, which is nothing but 3 times. Now this compound formation is indicated by color, and the color of this compound is termed as Persian blue. And the IUPAC name of this compound is iron 3 hexacyano ferrate 2. Iron 3 hexacyanate ferrate 2. It is also termed as ferric ferrocyanide. Now the question arises, like, if at all if the organic compound contains sulfur also, then what would be happening? If the compound contains carbon, nitrogen, and along with that sulfur, then we will be having the formation of NaCNS, which is termed as sodium cyanate, thiocyanate. Sodium thiocyanate. Formation of this compound is indicated by when we add FeCl3, we will get so this compound formation is indicated by the appearance of blood red color. If blood red color is formed, then we can confirm that organic compound contains nitrogen as well as sulfur. But students, on another hand, if at all if we take a little bit of excess of sodium, and in the compound there is a formation of a sodium thiocyanate, okay, but we will not be getting blood red color. The reason is that if we take a little bit of excess of sodium metal, then this compound will undergo decomposition, and there will be formation of Na2S plus sodium cyanide So therefore, care should be taken that when we are going for the detection of presence of nitrogen as well as a sulfur, for the presence of sodium thiocyanate, blood red color, if it does not appear, it doesn't mean that the compound is not containing nitrogen and sulfur. There might be chances that if at all if we take a little bit of excess of sodium metal, then that sodium metal may decompose this sodium thiocyanate into sodium sulfide and sodium cyanide, right? Now we will go for detection of sulfur. Detection of sulfur. So basically we can say that sulfur present in the organic compound will combine with sodium to form sodium sulfide. So this sodium sulfide can be detected by means of two reactions. One is by the addition of lead acetate. Addition of lead acetate to a little amount of sodium fusion extract where sulfur is present in the compound will give rise to the precipitate of PbS. This PbS, which is simply termed as lead sulfide, will be appearing as black precipitate. Will be appearing as black precipitate along with the formation of sodium acetate. Along with the formation of sodium acetate. One more method is there for the detection of sulfur in the organic compound, and that one is by the addition of sodium nitroprusside. So by the addition of sodium nitroprusside to the sodium fusion extract containing sulfur, we will get Na4 FeCN 5 times NOS. Formation of this compound is indicated by appearance of violet color. Appearance of a violet color. So this reagent is termed as sodium nitroprusside. So for the detection of sulfur, there are two reactions. One is by addition of lead acetate and other one is by addition of sodium nitroprusside. So for addition of lead acetate, we will be getting a black precipitate, but whereas for sodium nitroprusside, we will be getting a violet color. Is it clear, students? Now we will be moving with the detection of halogens. Halogens, basically we can say that it might be Cl or it might be Br or it might be iodine. So the halogen present in the organic compound, when we are going to treat it with sodium metal, if at all if it is Cl, then we will be having here NaCl, or it might be NaBr, or it might be NaI. So here for the fusion extract accompanying sodium chloride NaCl, if we add AgNO3 silver nitrate solution, then we will be getting formation of AgCl along with the formation of NaNO3. When AgCl is formed, it is indicated by the precipitation, and that precipitate is nothing but a white precipitate which will be soluble in excess of ammonium hydroxide. Which will be soluble in excess of ammonium hydroxide. Similarly, if at all, if the organic compound was containing halogen Br, and if it is treated with AgNO3, then we will be having the precipitate of the type AgBr, whose formation is indicated by the appearance of pale yellow precipitate. Pale yellow precipitate, and this pale yellow precipitate is sparingly soluble in excess of ammonium hydroxide. And if the halogen was iodide, then on addition of AgNO3, we will be having precipitation of iodide as AgI, which will be yellow precipitate. And this yellow precipitate is found to be insoluble in excess of ammonium hydroxide. So question will be asked in terms of for detection of halogen. Right? We should remember, students, that for the detection of halogen, sodium fusion extractor, it is first treated with dilute HNO3, boiled, and then only AgNO3 solution should be added. The reason is that if at all, if we are going to add AgNO3, and if there was, apart from sodium halides, if there was a sodium cyanide, then it would have been interfering with AgNO3, and it would have been given AgCN along with the formation of NaNO3. Similarly, if there was sulfur present, it would have been appearing as Na2S, and on addition of AgNO3, we would have been got a precipitate of Ag2S along with the formation of NaNO3. So in order to avoid the interfering species silver cyanide and silver sulfide, it is very much essential for us to add dilute HNO3. On adding dilute HNO3, this cyanide will be eliminated in the form of HCN along with the formation of NaNO3. And similarly, sodium sulfide will be converted into H2S gas. Thus, it can be said that this cyanide and this sulfide species can be eliminated, whose otherwise presence in the sodium fusion extract we would have got the other precipitate. Now we are going to learn regarding about detection of phosphorus. Phosphorus present in the organic compound is detected by means of addition of sodium peroxide to that organic compound, and where phosphorus will be oxidized into Na3PO4 plus Na2O. And on balancing, here there are odd number of sodium, odd number of oxygen here. So therefore we can write here 2, 6, 6 plus 4, 10. So we can write here 5. And phosphorus is 2, we can write here 2. So on addition of sodium peroxide to the organic compound containing a phosphorus, phosphorus is conveniently oxidized into sodium phosphate. And this sodium phosphate, it is further treated with HNO3 and heated, where phosphate present in the form of sodium phosphate, it will be conveniently converted into H3PO4 along with the formation of NaNO3. Now to this H3PO4, we are going to add a solution of ammonium molybdenate. Along with that, we are going to add HNO3. On addition of this ammonium molybdenate, we can say that there is a formation of a yellow colored precipitate NH4 3 times, PO4 12 times, MOO3, along with the formation of NH4NO3 and H2O. On balancing this, we can say that there are 21 molecules of HNO3 and 21 molecules of ammonium nitrate and 12 molecules of H2O. So in this case, for the detection of phosphorus, we can say that sodium peroxide is treated with organic compound containing phosphorus, where phosphorus is conveniently oxidized into sodium phosphate, and this sodium phosphate is further treated with dilute HNO3, and on boiling phosphate is converted into H3PO4, and to this H3PO4, on addition of ammonium molybdenate solution along with HNO3, phosphorus is converted into ammonium phosphate with 12 molecules of MOO3 along with the formation of ammonium nitrate and H2O. So this was all about the detection of element like carbon, nitrogen, sulfur, halogens and phosphorus. Thank you.